Alright, welcome to the last video for section 5.3. This is B5.3D, like David. And we're going to go through, again, a couple more examples. So we're going to go through b to the 0 and b to the negative n. We're going to remember that here's our definition of b to, hang on just one second. Here's a definition of b to the nth power, and that's probably something that we will need to remember right there as a take-home message. B to the nth power is b multiplied by itself n times. B is the base, n is the exponent. So let's go through a couple of examples of using some of those rules. And again, this is our homework, I suppose, and right here is going to be our problems that we have. And we're going to simplify. When we simplify, we write things with positive exponents. So in math, we don't like negative exponents, so we're going to have to write with positive exponents. So here's what we're going to do. We're going to say that we're going to kind of separate this and conquer. So if we say this is a cubed times, I'll make that a cube, times b to the negative 2 power times 1 over c to the negative 5 power, we can see that we can kind of apply some rules here and say, oh, hang on a second, this would be a cubed in our numerator. This would be, well, let's see, let's go the long way, I guess. A cubed, hang on just a second. This would be a cubed times 1 over b squared times c to the 5th power. And that would give us a cubed in our numerator times c to the 5th power over b squared. And there's our answer. So if we go through kind of the definitions, we can see that we go through one step of definitions, another step of definitions, then we get to the answer. We could also say that, well, if I've got a cubed stays on the same side of the divided by sign. B to the negative 2 power becomes b to the positive 2 on the other side of the divided by sign. C to the negative 5th power becomes c to the 5th power, positive 5th power, when we flip it over to the other side of the divided by sign. So there's our shortcut, I guess, for answering some of those, or kind of working with some negative exponents. Our answer now is in all positive exponents, a to the 3rd power, c to the 5th power, divided by b squared, and all of a sudden there we've got an answer. All right, let's try another one. Let's try the one to the right. Again, I'm going to encourage you at any time to pause these videos and say, what would I get for an answer? See if I get the answer that is in the video, and we'll go from there. Alright, so here is a couple of things. We've got an x to the negative 2 power, and we've got a base, an entire base, to the negative 2 power. So what you could do probably, there are a couple different ways you can solve this now. You could say, now I'm going to distribute this negative 2 power to each of these powers inside. Or you could take this negative 2 power and take the base, reciprocate the entire base, and then change the negative 2 power to a positive 2 power. Or you could simplify what's inside the parentheses. So I think that's what I'll try to do. I'll simplify what's inside the parentheses, and I'll say let's see, I'll change to red here. I'm going to say, you know what, I'll change to black. Alright, so here's my base, and I'm going to simplify my base, because later on I'll take everything to the negative 2 power. And I will simplify the base by saying, well, I've got negative 5, and I've got y cubed over x squared. And all I'm doing is taking that x to the negative 2 power, putting it in my denominator, because I'm keeping the base, moving the base to the opposite side of the divided by sign, changing the negative 2 to a positive 2, and that then is my simplified base. There's my simplified base. Now I've got everything in positive exponents, but now I've got to remember that I've got to keep that negative 2 power to on the outside of the entire base, because here's my base in the black, and the black has not really been changed. It's just simply been modified, so we have positive exponents, and the negative 2 power is still applying to that base. So now let's use our definition of negative 2 power, and we'll say that If we take our base and write it as a reciprocal, so the reciprocal of negative 5y cubed over x squared is x squared over negative 5y cubed. There's my reciprocal, and now if I write my base as the reciprocal, then I can write my negative 2 exponent as a positive 2. So there's a positive 2. And now we've got a simpler version of what we had before. And now we can just simply write x squared squared over negative 5y cubed squared. And that would give us x to the 4th power, because 2 times 2 gives us 4. And this is negative 5y cubed squared. So negative 5 squared is 25. Y cubed squared is y to the 6th power. And there's my answer. X to the 4th power over 25 y to the 6th power. Alright, for this one down here, z squared over w to the minus 4 times w to the 4th power times z to the minus 8th power. Sometimes you don't want to attack the negative exponents right away. You can just simply kind of separate and conquer. You can kind of take a look at the z's and the w's separately. So let's take a look at the z's separately. This would be, if we're talking about the z's, this would be z to the squared minus negative 8 power. And this is just simply an application of our z to the squared over z to the negative 8 power, z to the 2 minus the negative 8 power. The w to the minus 4 times w to the 4th power, if we take a look at that, just that by itself, w to the minus 4 times w to the 4th power is going to be w to the minus 4 plus 4 power is w to the 0th power, and that would be, we can write that as w to the 0th power. What's w to the 0th power? What is anything to the 0th power? That would be 1. So we can just simply write that as 1. We're assuming that w is not equal to 0, so that we can apply the rule of anything to the 0th power is just simply 1. So that would be 1. So now we only have to deal with just the z's. So now I've got z to the squared power minus a negative 8 equals z to the 2 minus a negative 8 is 2 plus 8 is z to the 10th power. And then there's our answer. So let's take a look at the next one. 3x to the negative 3rd power, y to the negative 2 power over 4x, y to the negative 3rd power. For all these, we really have to take a look at what the base is, what the exponent is. So let's take a look at, again, probably trying to simplify what's inside this parentheses, what's inside our base before we apply negative 2 power. Again, if you decide you want to apply the negative 2 power to each individual factor that's in here, you certainly can. But what I'm going to try and do is simplify what's inside the blue as a factor, or sorry, as a base, and see what we can do then to apply the negative 2 power outside as an exponent. Because again, here's our exponent working on our entire base. So let's take a look maybe at 3x to the negative 3rd power, y to the negative 2 power over 4x times y to the negative 3rd power, and see what we can do to simplify these. So let's take our number out first, and we're going to say that this is 3/4 times everything's inside. Now let's take a look at the x's. If we take a look at the x's, this would be x to the negative 3rd power minus 1, because here's again an unwritten rule that there's the x to the 1st power. This would be x to the negative 3 minus 1 power, and this would be y to the negative 2 minus a negative 3 power. And then all this would be to the negative 2 power. So we're just kind of trying to simplify what's inside here as our base. Right over here in our parentheses, I'm going to write down here, because we can kind of write down here for this example here. So we're going to go 3/4 times x to the negative 4 power, y to the negative 2 minus a negative 3 is negative 2 plus 3 is y to the 1st power, all again to the negative 2 power. This would be 3/4 times y to the 1st power, or just y, because that stays up above the divided by sine x to the fourth, x to the negative fourth power becomes x to the fourth power on the denominator side. And again, this is still to the negative 2 power. Let's simplify this. This is 3y over 4y to the fourth power, all to the negative 2 power. If we take our definition, we would say that this is 4y to the fourth power over 3y. Oops, sorry, did I change my x's? This is x to the fourth power, x to the fourth power. Here's an x to the fourth power, because this is y over x to the fourth power, y over x to the fourth power. We've now taken this base, we've flipped it, we've made it a reciprocal. 4x to the fourth power in the numerator becomes 4x to the fourth power in the denominator, and 3y becomes 3y in the, instead of in the numerator on the top, we can put it in the denominator on the bottom, and that way when we take the reciprocal we can change the negative 2 to positive 2, and now we just simply say this is our answer. 4 squared times x to the 4 times 2 is 8 power over 3 squared times y squared, and that should be our answer. We could even simplify the 4 squared to be 16 and the 3 squared to be 9, but that should be our answer. And if we want to, we can just write it as 16x to the 8th power over 9y squared, and that would be our answer. Alright, the others, I'm going to leave. I don't want this video to get too long, so we'll leave these for maybe some examples in class. Alright, any questions, bring them to class. Take a look at the video again. We'll look at some of these descriptions and definitions and examples in class.